Welcome surfers, it is Joel and this is a coding sound lesson 4, coding sound in C++. At this point we have a plugin shell that compiles, that can be loaded into a DAW, but at the moment simply process silence. Now, we need to make this plugin react to the outside world. So we are now going to modify the code to interact with a MIDI instrument and to detect MIDI notes. We cannot generate the sound yet, so we will visualize the notes on the graphic user interface. To do this safely, without any looking to the processing block, we need a special variable called atomic variable. It's part of the standard library and is a kind of special variables that multiple threads can read and can write safely at the same time without using any special mechanism like a mutex. So it is very easy to use. For the atomics variable is the hardware that guarantees that each operation on these variables happens all at once. So you in this case never get corrupted or half written values. Let's start with the code. The first code to modify is the processor header. We need first of all to include our atomic. Perfect. And now we need two atomic variables, two integer, one for record the last note number and another one to count the note that you play with your MIDI device. Std atomic integer last note number. The first one is -1. -1 means that no note are pressed to this moment, is the initialization value. And after this we have another standard atomic integer okay, and this is the note on count. In this case we can start from 0. Perfect. Now let's save this header and let's go to the plugin processor C++ because we need to update also the logic. The majority of the code here is the same, but inside the process block we need to iterate the MIDI message buffer to get our note number. So in this position we can start iterate with a for cycle the MIDI messages. Perfect. The first thing to do is to get our message. So out of message equals to metadata get message. Okay. Now we need to check if the message is a note on event, so if a real note is pressed. If our message is a note on message is the right spelling. we can update our atomic variables. So the last note number is written with the store method and becomes the message get note number. Okay, and the note on count simply need an increment of 1 unit. Okay, we can save the plugin processor, and the rest of the code is more or less the same of the last lesson. Now, we need to update the graphic user interface because we need to show these numbers that we read inside our process block. So we move to the plugin editor header, and the graphic user interface need to refresh itself at a specific period. In JUICE we can do this simply by inheriting for the standard JUICE timer. In this way the graphic user interface can run a function at a specific set interval, for example every 16 times a second. So to extend and inherit, in this case, the timer, simply we can write public JUICE timer. We need a column here, okay. And now we need to add a method called by the timer. So void timer callback, and this is an override. Okay. Finally, we can implement the real logic of the graphic user interface inside the plugin editor C++. In the constructor, we need to start the timer, and we need to say that the timer must be called every 60 milliseconds. So here inside the constructor we simply start the timer every 60 milliseconds. It's a good practice to stop the timer inside the structure of the class. Actually is empty, so we can simply stop the timer here. Good. This is a really important good practice to avoid any kind of trouble. Now we need the timer callback function that we declare here. Write it. This is void. Okay. Coding sound synth audio processor editor timer callback. Okay. And inside the callback we need to tell to the operating system that the component needs to be redrawn. And this is very simple. We use the repaint function, and the operating system each 16 milliseconds call the paint function of the component. This is the paint function. Now inside the paint function we need to do some changes. First of all, we need to read the atomic variables, and to do this we use our atomic value, and the the function load available in any atomic variable. So our note is equal to the audio processor last note number load, and the count is equal to audio processor note on count load. We have these two values, and now we need to draw something inside the user interface. So the first thing to draw is a text. Our lesson is a kind of MIDI debugger. This is needed to place correctly the text, and we can justify the text at the center of the window. Okay, it's enough to write a line of text. Now we can change the font. Okay. And we need to declare a text. If we don't have a note pressed, so if note is equal to -1, inside text we can put waiting for MIDI. Okay. If we have a note, the text is equal to last note with a space, and our MIDI message get MIDI note name note. And now add also the value of the note, so maybe with a space here. Okay, we can also delete parentheses. Okay, okay. Now we have the note name, the note number, but we also need to show the counter. So inside the text we can put a new line, total note on events, with a space and with our counter. Text. Okay. A little bit of formatting, so G, draw the fitted text, and we need to draw our text. And with the centered justification. I think that this code is enough to our goals. So let's try to compile and run this new version of our plugin. We miss something somewhere. Okay, we miss this. Try again. Perfect. To link our plugin, in this case run it in standalone mode with our MIDI device, we need to click Option, Audio MIDI Settings, and select the active MIDI input that we want to use. In this case I have a little MIDI keyboard here, and when I press a note, the magic simply happens. I have the name of the note, the relative number of the note, and a counter of all events, all note-on events generated by my MIDI keyboard. In this lesson you have successfully bridged the audio thread and the message thread. The audio thread is writing data at high priority, and the graphic user interface is reading this data at a lower priority. And using the standard library atomic variables, there are no loops, no waiting, and also no risk of any audio glitches. We now, at this point, have a safe environment to build a system, and we have a way to handle our MIDI input. And so we are now ready to the most exciting part. So in the next video we will generate our first sound of our plugin. Let's see in the next video.